I'm Dhanlakshmi from Sri Venkateshwara College of Engineering. Today I'll be discussing on user-based similarity, which is related to advanced AI and ML. So, user-based methods in AI, particularly in recommender systems, involve making predictions or suggestions based on the behavior and preference of similar users. This approach is a type of collaborative filtering which relies on the collective experiences of a group of users to recommend items. Here's how it works. So, in user based collaborative filtering, firstly they'll identify similar users, then they'll recommend generations. Like for example, imagine your streaming platform. If user A and user B have watched and highly rated several similar movies, the platform might recommend movies user B as a like to user A. So introduction to user-based similarity. So what happens is they'll compare users. User-based similarity analyzes patterns and relationships among users based on their interactions and data. Shared preferences. Users with similar tastes, behaviors, or preferences are considered similar in this context. So predicting behavior. Identifying user similarity helps predict future behavior. Personalize recommendations and enhance user experiences. So importance of user-based similarity is like personalized recommendations, like recommending products, content, or services relevant to individual user preferences. Targeted marketing, identifying user segments for effective marketing campaigns and personalized messaging. Fraud detection, detecting unusual user behavior patterns that may indicate fraudulent activity. So techniques for measuring user-based similarity is like basically it's jacket similarity, cosine similarity, pairs and correlation. So jacket similarity measures the ratio of shared items between users. Cosine similarity calculates the angle between user vectors, indicating the similarity based on the vector proximity. Pearson correlation measures the linear correlation between user ratings or preferences. Collaborative filtering and user-based recommendations. Identify similar users. Find users with similar past behavior, preferences, or ratings. Aggregate recommendations. Combine recommendations from similar users to create a personalized list. Preset recommendations. Display recommended items to the target user based on their similarities. So, profiling and its role in similarity analysis, demographics, so age, gender, location, and other demographic factors can influence user similarity. User interests, hobbies, and preference provide valuable insights for similarity analysis. Activity history, past interactions, purchases, and browsing behavior reflect user preferences and patterns. So challenges in implementing user-based similarity: data sparsity, cold or start problems, scalability. Data sparsity, limited user data can make it challenging to find similar users. Cold or start problem. Users with limited interactions history are difficult to analyze and recommend to. Scalability, handling large-scale user data sets require efficient algorithms and computational resources. So, emerging trends in user-based similarity, contextual similarity, considering user context such as time of day, location, device for more accurate analysis. Hybrid approaches, combining user-based similarity with context-based techniques for comprehensive recommendations. Explainable AI, providing transparent and interpretable insights into user similarity and recommendations. So, case studies, applications of user-based similarity, e-commerce, recommending relevant products based on user browsing history and purchase patterns, streaming services, suggesting movies and shows based on user ratings and viewing history. Ethical considerations in user-based similarity, privacy, ensuring user data is collected and used responsibly and ethically. Bias, addressing potential biases in user data and algorithms to ensure fairness and inclusivity. Transparency, providing users with clear explanations of how their data is used and how recommendations are generated. So let's watch a video to understand about this concept better.
Filtering technique. First, I will discuss the methodology used in system. The technique used to identify relationship between pieces of data. This technique is frequently used in recommender system. to identify the similarities between user data. And if user A like virus and protein products the user like and their characteristics to see what users who like products with similar characteristics. The model then makes recommendations accordingly. Product features should be given numerical values whenever possible, as it makes decisions by the model more accurate. That is, wherever possible, better to give the numerical values to the features rather than giving the string kind of data or something. Once the features are identified and assigned values, data collection needs to begin here. There are two ways the model can make or can identify whether or not a user enjoyed product. The user can be asked to give numerical ratings, or the system can assume what the user likes about a particular product. For example, whenever a particular user bought a particular product or something, we can ask him to give, we can say that the star rating like 1 star, 2 star, 3 star, and so on. Based on that, we can understand what product the user liked and so on. Considered fourth, and wherever there is a null or something, the meaning is user has not liked that particular product here. Now, if you closely look at this particular data, you can see here the product 3 has been liked by user 1 and user 3, because this product 3 is being liked by user 1 and user 3, and user 1 like product 2 also. So what we can do here is we can recommend this particular product 2 to user 3. This is possible. Similarly, if you look at this particular part of data, product 4 was liked by user 3 and 4, this I am talking, and user 3 likes product 3 also. So we can recommend this particular product to user 4. That is possible here. Now, if you look at this particular user 2 like product 1, but this particular product 1 was not being liked by user 1, 3, 4, and so on. So this particular product cannot be recommended to any other user. But this particular kind of recommendation can be done, like recommending the product 2 to the user 3 and recommending product 3 to the user 4 is possible. Similarly, if you look at another possibility, the product 3 has been liked by user 1 and 3, and user 3 like product 2, 4 also. So we can recommend this particular product 4 to user 1. So that is also possible. Now, if you look at this particular thing, now we have recommended this particular product 3 to the user 4, and the user 1 has already liked product 3. So now user 1 also like product 2, the same product can be recommended to user 4 also here. Now if you look at this particular thing, all three products were recommended. Some users have already can say that they have liked the product. Based on this particular data, that product can be recommended to other users also. So this is how the recommendation works in collaborative filtering. It's a very simple example, but with this you will be able to understand how actually the collaborative filtering works in machine learning or recommender system.
That's all about this video. I hope you understood what's about this concept. Thank you for watching this.